Hi, good morning, everyone. Today's session was pretty amazing, and I just wanted to do a quick recap. So, what we kind of figured out is how Egyptians came up with the area of the circle, which is quite remarkable. Okay, so the Egyptians' papyrus scrolls essentially said, if there was a round field of diameter 9 ket, which is a measurement that the Egyptians used, what is its area? And the first question that comes to mind is, why do the Egyptians care about this, right? And the way it kind of worked is that Egyptian pharaohs collected taxes, okay, from the people. And in a case where, again, the Egyptian lands were next to the Nile River, and any point in time, if the river flow was significant, the river would flood the surrounding areas, and the Egyptian farmers would lose their crops. And therefore, they would ask the pharaoh and say, Pharaoh, we can't pay the taxes because half of our land is gone. And as a result, the pharaoh would send these surveyors who would come and take a look at the land, and they would measure the area and see how much tax they really owed. So computing an area was very, very important for the Egyptians. So that's why they're kind of really good at, geometry. So this part is really fascinating, right? So they essentially said, if there is a round field where diameter is 9 ket, what is its area? Okay, and they then solve the problem, and they say, take away 1/9 of the diameter from the original diameter. Okay, in this case, if the original diameter was 9, when they take 1/9 away, that's 1/9 of 9, 1, right? So they take 1 away. What is your remainder? Your remainder is 8. And then they take 8 and multiply it by 8, and they get it 64. So the area according to them was, for something that is 9, it is 64. Now, given the fact that today, we kind of have the area of the circle as pi r squared, right? So a 9 would lead to a radius of 4.5, right? If you were to square 4.5 and multiply it by pi, it gets pretty close to what the Egyptians came up with. So one of the things I wanted to take a look at is figure out from this statement what the Egyptian formula was for an area. Okay, and then let's compare it to our formula and see how close were the Egyptians. Okay, so that's sort of our goal today. Now, the first thing we need to figure out is how did they do this? Let's translate their solution, right, into a formula. But first, we're going to essentially use this number 9 as is. Okay, so first thing that they talk about, their step 1 in their approach was take away 1/9 of the diameter. Okay, so when we have an original diameter of 9, so that's our original diameter. Okay, so the original diameter is 9. And then this statement says take away 1/9 of the diameter. That means we take away 1/9 of this diameter, okay, which is 9. All right. So we take 1/9 away from the 9, okay, and then whatever the remainder is, in this case, we know according to it, which is that we take away 1, and 1 is essentially right here, right, which is 1/9 of 9, and the remainder is just 9 minus 1, which comes to 8, right? And their idea is whatever the remainder is, we square it. So the step 2 that the Egyptians have is whatever the remainder is, we multiply it by itself, okay, or which is same thing as squared, and that is the area. Okay, so now how do we translate the step 1 and step 2 into a formula? Okay, so now the first thing to do is that we circle the areas that are the diameter. Okay, and we're going to replace them by a variable, right? So we'll say, let's assume that our variable for diameter is d. Okay, so d is, in our case, the diameter. If d is the diameter, then we can rewrite this as d minus 1/9 of d, right? That all we did was we replaced these two nines with the variable d. Okay, now the step 2 then would signify that we squared this number, right? Whatever that remainder was, or in this case, this is equivalent of the 8, we square this number or we multiply it by itself. So in this case, an equivalent for this one would be we take d minus 1/9 of d, okay, and then we take the whole thing and we multiply itself, or we just square it, okay. Now the other part that comes to mind is, fine, so this is what the area of what the Egyptians came up with. So let's just rewrite this. So we say that the area according to the Egyptians is equal to d minus d over 9 squared. Now we can actually simplify this, okay? So how do we simplify d minus d over 9? So d minus d over 9 is simply, if you look at their denominators, we can easily subtract or add denominators if the denominators are the same. So how do we make 1 the same as 9? And the simplest thing to do is we multiply both the top and the bottom by 9, okay? So what does this leave it? It leaves it 9d minus 9 minus d over 9. Now the denominators are the same. If the denominators are the same, we can then subtract the top values, which is just 9d minus d, or it comes to 8 over 9d. Okay, now let's take this value and we can actually plug it in here. Okay, so now the area is going to be equal to 8 over 9d squared. Okay, so now this is pretty cool, right? So the Egyptians came up with the area of the square. Now we have to think about, okay, so what does that mean, for us, right? What does it mean when is it similar to what we come up with, right? How close is it? So that's going to be our next part, right? Which we're going to talk about how the Egyptian value of the area of the circle comes close to what we have. Okay, so let's do that now. Okay, so in the last part, we said area according to the Egyptians was 8 over 9d squared. Okay, now that's what the Egyptians came up with. And let's compare to what we come up with, right? So in our case, we know that if a circle has a radius of r, okay, if a circle of radius of r, we know that the diameter is just twice the radius, right? Basically, a diameter is the full part here. So we know the diameter is equal to twice the radius, or in other words, radius is half of the diameter, okay? Now, the area of the circle that we all know of is area equals to pi and times the square of the radius. So we're going to use d over 2 and we're going to plug that in instead of the radius, right? Because Egyptians did everything with diameter, so we'll work with the diameter only. In that case, area will be equal to pi times d over 2 squared, right? So all we did was we plugged in d over 2 into r and we're going to square it. So this becomes pi into d squared over 4, okay? Or another way to write it would be pi over 4 times d squared, okay? Now let's compare to this guy here. Let's expand this guy out, okay? So we're going to open the square up. So the top part will become 64 because we just square the 8, then we square the d, and then we square the 9, and we get an 81, right? 9 times 9 is 81, 8 times 8 is 64, and d squared is just d squared. So let's just say this will be 64 times 81 times d squared. Now, in order for us to compare the two, we know that both the formulas have d squared, which is similar, right? So that means the only difference would be between these two terms right here, 64 over 81 and pi over 4. So let's see how close were the Egyptians to computing the right value of pi. So these two have to be equal, right? So if pi over 4 is equal to 64 over 81, pi would be equal to 4 times 64 over 81. Okay, now that, let me just pull up a calculator so we can see what that would come out to be. So let's say in this case we are going to compute this value. as 4 into 64 divided by 81. This value comes to 3.160. 3.160, which is very, very close to the value of pi that we have, which is 3.14159. Okay, so that is really, really cool. And the fact that the Egyptians came very, very close is quite remarkable. Okay, so I hope this kind of makes sense. The next topic we're gonna cover would be why is it that the Egyptians came up with something like this, right? Is there a reason and purpose behind their use of this 1/9 formula, right, in order to come up with their approach to the area of the circle. Okay, I hope you enjoyed it, and my next session will cover that shortly.